Fabric? Yes, that works. SQL Database running on Microsoft Fabric brings transactional workloads in Microsoft Fabric. Today we will learn how that works. Have a look at the Fabric periodic table. We see that SQL Database is well described here, and we have some common scenarios, especially for applications. And this is one of the hero use cases, that when you have an application, like a web application that needs a SQL backend, a SQL Server backend, that you use SQL Server running directly on Microsoft Fabric, with the benefit that all the data is directly mirrored into OneLake. And you have all the benefits of the Fabric platform. So let's understand and let's draw how an application, let's start on top here, application, interacts with the SQL Server or SQL Database running in Microsoft Fabric. So this application accesses the SQL Database via TDS or GraphQL. So there's, let's say, a write. Now we are in our Fabric workspace. The request goes to the SQL database via read-write OLTP. So this then goes into the change feed. The change feed leads to Delta Parquet, obviously, because it's OneLake. So now we are in the outer mirror, which uses a change feed. The outer mirror uses the change feed to bring the Delta Parquet into, let's shift to blue, OneLake. There we see our data as Delta Parquet tables. So that's one of the big benefits we have. Straight away we have tables. Now we can access the tables in a variety of ways. The most obvious one might be, because we are talking about SQL, the SQL Analytics Endpoint. This is read-only and is based on T-SQL. We have a separate video why this is read-only. Was the last one. So this is one path. The other path, because we have OneLake with Data Parquet, would be Spark Notebooks. Spark Notebooks. From the SQL Analytics endpoint, we could go to a warehouse or a Lakehouse with 3 part names, or we can go with a semantic model directly. For example, to Power BI. And since we can go from Power BI directly to OneLake, we can use Direct Lake. But just remember, there are some constraints. like views in a Lakehouse or something like that, where direct lake doesn't work. Dive a little bit into the SQL endpoint. To do that, we first need a Lakehouse. So, oops, there's something I should resolve. Okay, so let's create a Lakehouse. It's pretty straightforward. Let's say worldwide importers Lakehouse. Create. And the next thing is that we will ingest some data into that Lakehouse. We will do it with an data flow gen 2. This is customer mention data. Okay, and next we will import that from an file. I will upload the file. So file is uploaded. Very straight. So let's create our table. This is dimension customer. So let's rename that. There we go, dimension customer. And we can, well, we have already the Lakehouse configured because we started it from the Lakehouse. So we can simply say save and run, and it will import the data. So our run is succeeded. You can see it here. So let's go back to our workspace. Let's have a look. The Lakehouse refers to DBO schema. And we have the dimension customer in here. To work, we need some more data. Well, it's curring. So let's jump back to the workspace. And let's create a pipeline. There we go. Ingest data from source to Lakehouse. So, and from there we can add a pipeline activity, and we will use a copy data activity. And when we click on it, we see the properties down here. This is the data copy to Lakehouse. And in the source field, we will connect by browsing all. We'll go to Azure Blobs. There we go. And there's an Azure Blob endpoint with sample data that we can use. There we go. Pretty straight. Okay, connection is done. And now we need to fill in the path, the sample data. Sample data, wide world importers, data warehouse, Parquet. Which is okay. So we need the binary format because we have Parquet. That looks really good. And let's switch to the destination, because there we want to import that in our Lakehouse, which we will find in the OneLake catalog, this Lakehouse. And we will put that in the files section. This is nice because I can show you then how to move files to tables. And the path is WWI raw data. File format is binary, so that looks really good. Let's save our pipeline and let's run our pipeline, and I will be back once the run has succeeded. Our run was successful, and now under the file tabs we have the Parquet files. And the next thing that we need to do is to import these Parquet files into our Lakehouse, so we can start playing around with the Lakehouse data. But how is the read-write handling and the data access exactly? Because, well, you can access this from OneLake, you can write it via TDS. Let's have a look. So we have first the so-called write path. This means you can write here, right? So you have the web app, for example. Just an example. You might have a mobile app. You might have a data pipeline. Just something. The web app might write through the TDS protocol. The mobile app might use GraphQL, and the pipeline might use copy activity. Either way, everything ends up in .mdf, yes, MDF files, which means it's running on the SQL database engine. So from there on, we have the well-known transaction log, keylog. Every SQL-based system has something like that. Every I know at least. And now we are entering the so-called mirror path. This is running automatic. The mirror path means we have a change feed, which is populated by the transaction log. It's system managed as automatically, and in near real time we write into data Parquet, which means let's do it again, blue OneLake. In near real time we write into OneLake. So this is like the mirror path. From there on, we entering the read path. The read path means we can go to the SQL Analytics endpoint. We can go to Spark Notebooks. We could go to Power BI Direct Lake. And of course, we could do cross-DB joins from the SQL Analytics endpoint, cross-DB, with other warehouses or other lakehouses. No problem. So this is the read path. So when we have like a high-level look, we see we have the write path. We write into MDF files, we have the mirror path, which mirrors everything automatically into OneLake. And then we have the read path. Funnily enough, from Power BI, we can do write back into SQL database running in Fabric. There's a write back capability. So Power BI could like feed itself somehow. Variety of options to run SQL code in Microsoft Fabric. Let's explore the options and let's draw a decision tree basically. So We start off with I need SQL in Fabric. So this is my need. From there on, the first question is, do I need OLTP transactions? If I don't need OLTP transactions, no, analytics only. Then the next question is, do I prefer SQL or Spark? So, when I prefer SQL writes, oh, that's not nice, SQL, then I will go with warehouse. When I am a Spark first guy, then I will go with Lakehouse. Let's go back. Do I need OLTP transactions? Let's say yes. OLTP. Then, next question is, do I need VNet, CDC, always encrypted, full text search? If yes, you guess it, these are all features of the Azure SQL Database. Then I'm in Azure SQL Database. If no, then the question is my capacity, my Fabric capacity, larger than F8? If yes, then I have enough CU headroom. Then I will go with SQL Database in Fabric. If I don't have F8, then I am at cost risk, because I have this 15-minute minimum runtime, and this might dominate my CU. So this is a risk. So let's have an overview again. I need SQL in Fabric. Do I need OLTP? No, then I can end up with warehouse or lakehouse. If yes, then the question is, do I need any features that require something like SQL database in Azure? Or do I have a capacity smaller than F8? Then I need to check whether my capacity really gives me the room to run SQL database in Fabric. So that's the decision tree. Our run was successful, and now under the File tabs we have the Parquet files. And the next thing that we need to do is to import these Parquet files into our Lakehouse, so we can start playing around with the Lakehouse data. Okay, so we will do the import with a notebook. So let's go to our workspace. Oh, excuse me, my fault. Click Import, Notebook, and let's select the notebook from my computer. So I've selected the notebook, and the notebook import is in progress, and we can simply open the notebook, and we will see the content of that notebook. And when you have a look, it creates some data frames and then writes the data frames in the tables folder. So that's the purpose for the fact table and for the dimensions. So it's a pretty straightforward, right? So let's run this story. Okay, so let's run our notebook. I've set the WWI Lakehouse as default Lakehouse. And so now everything should be nicely executable. So we run the fact sales table. Spark job is started. And you import the fact sales 1 year full and create our table with the table name fact sale. And then we can create the dimensions. And basically then we have built our lakehouse here. Let's refresh. There might be already something. Not yet. I will return once everything is in there. Okay, now we have some tables in our lakehouse. And we have the switcher on the top right between the Lakehouse view and the SQL Analytics Endpoint view, where we see our tables. Not all yet. Let's refresh. Yeah, there we go. Dimension city, for example, or the fact sales. And we can, for example, make a new SQL query by selecting the top 100, and it's executed and we see the results. Reuse and charging and so on. Let's have a deeper look in how compute is really charged. So we need to talk about the life cycle of a SQL database. So we have a SQL database life cycle. So like the idle state or the pause state means that it costs you 0 CUs, storage only. So you have to pay for the OneLake storage that the SQL database needs. When you then, from there on, run your first query, the query arrives, and there is a wake up call. From there on, the compute is allocated. Now the compute is active, obviously. So let's draw that in red because it's active. Active means CPU plus 2 gig of RAM minimum memory. So this is active now. Next thing what happened is, well, the query is then done. Query done. Then the cooldown starts. Cooldown. It's a 15 minutes timer. So after 15 minutes, the cooldown will happen. When there are more queries, the pool stays active and the timer starts from the very beginning again. After 15 minutes of inactivity, 15-minute no activity, then we are back in the idle state. Okay. So what does it mean regards billing? So The cooldown means 2 gig of memory plus approximately 2/3 of vCore multiplied with 2.611 CUs, just an approximation. When the active state is running, it's approximately max vCores, of course, depending on your F capacity, max vCores. And memory of 3 gig multiplied with 2.611 CU. The idle state, last one, let's grab it from here. Idle means storage only. So this is the point. The point is not that you pay when you are active. That's fine. The point is not that you pay when you are don't pay when you are idle. That's perfect. The point is that you pay for the cooldown. This is the 15 minutes window that hits you every time the cooldown starts. And the worst thing, of course, that can happen is every 60 minutes, one small query, or every 14 minutes and 30 seconds. Yeah, so the cooldown phase then is endless, but you pay most for the cooldown during the day. In the properties, we have also our SQL endpoint that we can copy, and then we can go to, for example, Visual Studio Code and add a new connection and use that connection string to connect to our data. So this is how it looks like in VS Code. You see the tables here. The columns and keys and all that stuff. It's pretty straightforward, I think. We can even edit the tables. It's quite nice. We can create a new query. So I've copied the query that we have just created online. Let's run it here. So you see it's obviously the same result. It's a security, and let's run let's create a schema named reports first, and then we will create a view report state summary with all the fields. That's pretty straightforward. Then we will grant myself, so my user, select on this object, and we will deny the select on the base table. So I can basically see the view, but I cannot see the baseline table. That's the plan. And I think I have to execute that because it's myself currently running under a different user. I will do that, and then we can test. So I have now applied the access to my colleague, and he just confirmed that it works. So he can see the view, but he cannot see the table anymore. And last but not least, let's have a look at the performance. I have created 2 different semantic models, one with a view included and one not. This is the best practice analyzer for the one that don't include the view. And this one is the best practice analyzer that includes the view. And you see that there's a performance impact when we use views in semantic models, because we enforce basically a direct query mode. We can see it when we go back to our workspace. When I have a look at this semantic model, you see there are the 3 tables in there. And when I go back to the workspace and I go to the view semantic model, then you see that there is also the state summary, which is a view. The type is not correctly displayed here. This is a view, and this forces the performance issue. So be careful with including views in semantic models regarding performance. In SQL databases on Fabric, that always comes on top of the mind. This is a so-called translytical pattern, OLTP plus analytics in one. So translytics equals OLTP plus analytics in one. So let's talk about that. So we will start off with an operational layer. And the operational layer, let's say, is a web application that sits on top of a GraphQL REST API. It makes create, update, delete operations on the SQL database with the OLTP engine. So this is our operational layer. Operational layer, web app, REST, CRUD on top of CRUD on top of SQL DB. Now let's say we have some, well, it's 2026, so we have some AI functions in here, AI functions that are running on top of Azure OpenAI, Semantic search, RAG, and so on. Let's say we have some automatic mirroring because we have a SQL database. Into OneLake. In data Parquet, of course. So this is our automatic mirroring. And from there on, we feed two different items. The first one is our analytics layer. And there's a SQL analytics endpoint. And the second one are our Spark notebooks. For data science, for example. And from the analytics endpoints, we can work with Power BI reports in direct lake mode. When you resist to use the stuff that renders the direct lake mode invalid, we can work with joins on a warehouse layer, and we can work with joins on the Lakehouse layer. So we can write our data and we have reporting all in one. This is the so-called translytical pattern. And you even could write back from Power BI to your SQL database. Then you have even like a fancy twist in there. Look at the community. There was a big Ask Me Anything from a Microsoft PM regarding SQL databases. There was some top community feedback. The first one is CU cost is a non-starter. So users report that even an idle database, because of the idle time, consumes significant CUs due to engine warm-up and cool time and so on. Some even noted that it's more expensive than event streams. So comparison with other workloads shows that there is some kind of disproportionality towards SQL database. The F2 capacity was blew up with small instant workloads. So the metadata framework overhead alone overwhelms the smaller capacities, and the metadata framework is too expensive for F2 F2, F4 capacities. The background mirroring and all the catalog sync eats into the CU budget before any user query even runs. So this is basically the core part. So users report, for example, that they just run 48 lightweighted stored procedures calls per day and seeing unexpectedly high CU consumption. The SQL engine starts at large size regardless of workload with a long cooldown period. The user reported 20 to 25 minutes. And there's like an all or nothing engine startup. So the engine starts or is not started. There's nothing like in between. A community recommendation in that case is, of course, use an external SQL database with a function as a service or something like that. How about Fabric Data Warehouse versus Fabric SQL Database? So how does the CU billing differ between the different Fabric items? So SQL Database has an interactive billing with a 15-minute minimum per session. Warehouse has background billing, more forgiving for burst workloads, and the cost comparison is about Azure SQL DQ Basic at $6 per month versus F2 capacity at $182 per month. So this is again the problem with this 15 minutes billing window. So for cost-sensitive workload, there might be even the warehouse cheaper, despite it's designed for analytics. And the Translytical value proposition only pays off when you really need both OLTP and analytics on the same data. Users ask also how to connect to Fabric SQL Database from Spark notebooks for CRUD operations. Discussions covers PyODBC, JDBC, token-based authentication, and so on. So basically, you need an Entra token-based authentication, and PyODBC will work with the driver version 18 or newer, but it requires token handling, and the GraphQL could be an alternative for that. There's also a question about how to structure and organize database projects with CI/CD, source control integration, and so on. So Git source control is supported. SQL packages can be used for schema deployment. And while CI/CD story is evolving, of course. Yeah. Can Microsoft Fabric be used as a backend for apps? Because of the SQL database capabilities? Yes, that's possible with the GraphQL and SQL database combination. The community is pretty positive on that. But of course, the concern is again the CU billing for high frequency API calls. So the common pitfalls are underestimating the CU costs, ignore the 15 minutes window, just put a job every 14 minutes or something like that. Expecting Azure SQL database parity. The engine is compatible, but not all features are available. There are documentations about that. And consider the mirroring overhead. It's a key feature, but it runs in the background and it consumes capacity units. So it's always about sizing. Pro tip is size your capacity in a proper way. Batch your operations and use the GraphQL API for integration instead of direct SQL connections, because then you have a managed API layer with authentication, so you have most probably less the need for additional middleware. Thanks for attending this time. When you want to get a notify once I release a new video, please hit subscribe, and I would be very happy to see you next time. Take care. Goodbye.